The first place that we're going to look at is angles that have a vertex at the center of a circle, here at the center of circle A. And as we've talked about, this is called a central angle. Make sure you have that term in your notes. It's very important. The measure of a central angle is going to be equal to the measure of the arc that it subtends or it intercepts. And again, when we talk about intercepting an arc, it means the arc is in the interior of this central angle. So it is therefore intercepted, or you'll also hear subtended. There are two types of angles with their vertex that are on the circle. So central angles is at the center. Well, inscribed angles will have their center on the circle, and we've talked about those already. Well, there's also tangent chord angles, whose vertex is also on the circle. As we've learned before, inscribed angles have a measure that is 1/2 the intercepted arc. So if the arc is 70 degrees, then the measure of the angle will be 35. Because its vertex is on the circle, it is half the measure of the arc. Tangent chord angles also have their vertex on the circle, and their measure is 1/2 of the intercepted arc. Tangent chord angles are made up of a tangent, which you recall is a line or segment that intercepts a circle at one place, and it's made up of a chord, hence the name tangent chord. All right, well, there are also angles that are inside the circle but not at the center, and those are called chord angles. As you can see, chord CD intersects chord EF at point G. Now, the formula for finding out the angle measure of a chord angle is 1/2 the sum of the intercepted arcs. So the measure of angle CGE would be 1/2 CE plus FD. To find the measure of angle CGF, it would be 1/2 CF plus the measure of arc ED. What do we have for angles with vertices outside the circle? Well, there's three different types. There is the secant-secant angle, the secant-tangent angle, and the tangent-tangent angle. Let's take a look at all three. A secant-secant angle is made up of two secants. You'll recall from the previous video that a secant is a segment that intercepts a circle in two places. So a secant-secant angle here at C will be made up of secant CG and secant CI. To find the measure of angle C, we simply take half the difference of arc GI minus arc FH. Now, secant-tangent angles are made up of a secant again, like CG, and a tangent, like CI. Once again, since the vertex is outside the circle, the formula for finding its measure will be 1/2 the difference of the intercepted arcs. So we'll take 1/2 arc FI subtracted from arc GI. Okay, finally, there's tangent-tangent angles. And we learned about the importance of two tangents meeting outside a circle, how the lengths of the two tangents are congruent. Well, to find the measure of their angles, we will take the difference in the major arc here minus the minor arc, and we'll take half of that. So, very briefly, it's pretty simple. If the angle has its vertex at the center, then the angle is equal to the measure of the intercepted arc. If the angle is on the circle, then the angle equals 1/2 the measure of the intercepted arc. If the vertex is in the circle, but not at the center, the measure of the angle equals 1/2 the sum of the arcs. And finally, if the vertex is outside the circle, the angle equals half the difference of the arcs. Okay, Ramblers, please keep in mind the important thing is to first figure out where the vertex is. It's either in the circle at the center, or just plain in the circle, like a chord angle, on the circle, or outside the circle. And then, once you know where the vertex is, you can recognize the different formulas for finding the measure. Okay, I'm going to attach a couple of tutorials to give you a little practice with this. Thanks for watching, and go Ramblers. Example problem 3 on page 473 gives us a chance to calculate the measures of some of the angles that come up in the video. The first one is the measure of this chord angle right there at inside the circle, but not at the center. And you'll remember, or you'll recall from the video, hopefully, that any chord angle is equal to 1/2 the sum of the measures of the intercepted arcs. So I'm just going to call those arcs AB and XY. And so in this case, the intercepted arcs are 88 degrees plus 27. So as the work shows you here, the sum of those arcs divided by 2 is 57.5. Now in part B we have a secant-secant angle. And as you recall, since the vertex is outside the circle, out here, we can know that the measure of the arcs is going to be 1/2 the difference of the intercepted arcs. And the intercepted arcs are going to be 57 and 31. So we just follow along with the work, and you can see that it's 1/2 57 minus 31, and so you get 1/2 of 26 degrees, which is 13. Finally, the last example is a tangent-tangent angle, which is once again outside the circle, out there at angle Z. And that is going to once again equal 1/2 the difference of the intercepted arcs. So that's 1/2 233 minus 127. And when you take half that difference, you get 53 degrees. Okay, let's move on and take a look at some angles, or some problems where they give us the angle measure and we have to find an arc. Okay, in problem number 4 on 473, we're given the measure of the arc. The measure of the angle is 72, and we have to find the measure of the arc. So we're going to use the same formula that we were using in the previous example, which is going to be 1/2 the sum of the intercepted arcs, which again I'm just calling AB and XY. But since we know the angle, we set the sum of the arcs, or sum of half the sum of the arcs, equal to the angle measure, which we know, 72. And it's the measure of the arc, or y, that we don't know. And so we just solve it by multiplying both sides by 2 and solving for y. Okay, in the secant-tangent angle in part B, same thing. We do not know the measure of arc Z, but we do know the measure of the angle out there at 32. So we set 32 equal to 1/2 the difference of the arcs and solve for Z. Finally, part C is maybe the easiest. It's just an inscribed angle, and we know that 65 is going to be 1/2 the measure of angle A, and that's exactly what they set up for us. That 1/2 the intercepted arc A equals 65 degrees, and they solve. Okay, Ramblers, we have lots of practice in this section to work on these, so good luck.